The last person to walk on the moon did so on December 14th, 1972. His name was Gene Cernan. He was 38 years old. He had been on the lunar surface for 3 days, with his crewmate Harrison Schmitt conducting the most ambitious geological survey of the Apollo program. They had driven a rover across the floor of the Taurus Littrow Valley. They had collected 250 pounds of rock and soil. They had drilled core samples deeper than any humans before or since. Now it was time to leave. Cernan climbed the ladder of the lunar module. He paused on the last rung, turned and looked back at the surface. He had scratched his daughter's initials into the lunar dust earlier that day. TDC for Tracy Dawn Cernan. He looked at the footprints he was leaving behind. He said into the radio, "We leave as we came, and, God willing, as we shall return, with peace and hope for all mankind." Then he climbed inside. The hatch sealed. The ascent stage fired, and the human species left the moon. It has been more than 50 years. No one has been back. Cernan died in 2017, at the age of 82. He spent the last decades of his life arguing, to anyone who would listen, in interviews and congressional testimony and public talks, that the decision to abandon the moon was the worst strategic mistake of the American space program. That every plan for going further into the solar system, every serious analysis of how humans actually reach Mars, kept returning to the same conclusion he had reached in 1972 while standing on the lunar surface. The conclusion was this: the moon is not a detour from Mars. The moon is how you get to Mars. This video is about why he was right. Start with the numbers, because the numbers are not intuitive. The moon is about 384,000 kilometers from Earth. Mars, at closest approach, is 54 million kilometers, roughly 140 times farther. The moon is 3 days away. Mars is 6 to 9 months away. If something fails on a moon mission, the crew can be home within a week. If something fails on a Mars mission, the crew cannot come home. Not for months. Possibly not ever. This is not a small difference. This is a categorical difference. We have never kept humans alive off Earth for the duration that a Mars mission requires. The longest continuous human spaceflight on record is 437 days, set by the Russian cosmonaut Valery Polyakov aboard the Mir space station in 1995. A round-trip Mars mission, including surface time, would last at least 500 days. Depending on the orbital geometry, it could last more than 900. We are, in other words, planning to send humans on a journey longer than any human has ever taken, to an environment harsher than any human has ever endured, with no ability to return them if something goes wrong, using systems that have never been operated together at the required scale. The question isn't whether this is hard. The question is whether we are doing the work required to make it survivable. The moon is the work. Consider what a crewed Mars mission actually requires. It requires a life support system that runs continuously without resupply for at least 2 years. It requires food production or storage at a scale never attempted. It requires radiation shielding for transit and for a surface with no magnetic field. It requires habitats that withstand temperature swings and dust infiltration over multi-year timescales. It requires medical systems for emergencies that cannot be evacuated. It requires psychological structures for crews in long-duration isolation. It requires propulsion, navigation, landing, ascent, and rendezvous capabilities that have never been operated as a single integrated system. Every one of these is a problem that can be tested on the moon, 3 days from home, with the ability to abort. A life support failure on the moon is a crisis. A life support failure on Mars is a funeral. This is the argument in its simplest form, and it does not go away no matter how many times it's restated. The moon is the only place in the solar system where we can practice being a multi-world species without betting the lives of the crew on getting it right the first time. Mars advocates sometimes argue that the moon is too different from Mars to be useful as practice. The lunar surface has no atmosphere. Mars has a thin one. The lunar day is 14 Earth days long. The Martian day is about 24 and a half hours. Lunar gravity is 1/6 of Earth's. Martian gravity is 3/8. These differences are real, but they are not the differences that kill astronauts. Radiation behaves similarly on both bodies because neither has a protective magnetic field. Dust infiltration is critical on both. Thermal cycling, equipment redundancy, in situ resource utilization, surface mobility, emergency medical response. These have to be solved for either body, and the solutions transfer. The differences are real. The similarities are larger. There is a second argument for going through the moon, and it is more technical, but possibly more important. In October 2009, a NASA mission called LCROSS deliberately crashed a spent rocket stage into a permanently shadowed crater near the moon's south pole. The impact threw up a plume of debris, which a trailing spacecraft analyzed. The plume contained water, not trace amounts, substantial quantities. Subsequent missions have confirmed it. India's Chandrayaan-1 detected widespread surface hydration in 2008. NASA's SOFIA Observatory directly identified water molecules in sunlit lunar regions in 2020. India's Chandrayaan-3 landed near the lunar South Pole in 2023 and confirmed the presence of subsurface ice. The current best estimate is that the permanently shadowed regions at the lunar poles contain hundreds of millions of tons of water ice, accumulated over billions of years in craters that never receive sunlight. Water in space is not just water. Split a water molecule into hydrogen and oxygen, and you have the two most efficient chemical propellants known. Water is also drinking water, oxygen for breathing, and shielding material against radiation. The cost of launching water from Earth to lunar orbit has dropped sharply in the era of reusable rockets, but it remains roughly between $1 and $3 million per ton, depending on the launch vehicle and trajectory. The cost of producing water from lunar ice, if a working ISRU system is developed, could be 1/10 of that or less. This changes the architecture of every mission that follows. A Mars mission launched from Earth has to carry every gram of fuel, water, and oxygen for the entire journey. A Mars mission staged through the moon, refueled in lunar orbit with propellant derived from lunar ice, can carry orders of magnitude more payload because it doesn't have to climb out of Earth's gravity well with all of its mission consumables loaded at launch. This is the tyranny of the rocket equation. Every kilogram of fuel you need at Mars requires you to launch many kilograms from Earth because most of the fuel you launch is used to lift the rest of the fuel. The equation is unforgiving. It is the single biggest reason that deep space missions are expensive. A lunar fuel depot doesn't eliminate the equation. It changes its structure. Earth launches become cheaper because they carry less. Mars missions become more capable because they refuel before the long journey. The moon becomes the first node in a transportation network that extends outward, not because anyone planned it that way, but because the physics works. Going through the moon by current estimates reduces the cost of a sustained Mars program by between 30 and 70%. The range reflects uncertainty about ISRU efficiency, depot architecture, and mission cadence. The direction does not. Going through the moon is cheaper than going around it. I want to take the strongest version of the opposing argument seriously because it exists and it is not stupid. The case against a lunar stepping stone has been made most prominently by Robert Zubrin, the aerospace engineer who founded the Mars Society and who has spent 4 decades arguing for direct missions to Mars. His argument runs roughly like this. The moon is genuinely different from Mars. The engineering you optimize for lunar conditions is engineering you may have to redo for Martian conditions. The institutional momentum that builds around a lunar program tends to absorb resources and political will, leaving Mars perpetually 2 decades away. And the historical record of crewed spaceflight in Zubrin's framing is a record of intermediate steps that became terminal. Programs that were supposed to be stepping stones became the entire staircase. There is evidence for this view. The International Space Station was justified in part as a platform for deep space mission development. 30 years and roughly $150 billion later, it has done remarkable science, but has not produced a single piece of hardware that has flown beyond low Earth orbit. Stepping stones in the Zubrin critique are where ambitious programs go to die. The counter to the counter is this. The choice is not between a lunar program and a Mars program. The choice is between a sequence program that builds capability incrementally and a direct program that assumes capabilities we have not yet demonstrated. Zubrin's Mars Direct architecture, first proposed in 1990 and refined many times since, is technically credible. But it requires a degree of risk acceptance and a degree of confidence in untested systems that has not, historically, been politically sustainable for crewed missions. The honest version of the debate is this. A direct-to-Mars approach is faster if it works and catastrophic if it doesn't. A through-the-moon approach is slower but more forgiving. Both are defensible. The question is which kind of risk a civilization is willing to accept on behalf of the humans it sends. For most of the past 3 decades, the political answer has been neither. We have not committed to either path. We have studied both, funded fragments of both, and committed to neither. That is now changing. In 1969, 12 days after Apollo 11 returned from the moon, the engineer Wernher von Braun stood in front of the Space Task Group convened by Vice President Spiro Agnew. He had a plan, a detailed one. Build a permanent space station in Earth orbit by 1975. Use it as a staging point for a lunar base by 1980. Use the lunar base as a staging point for a crewed mission to Mars by 1982. The moon, in von Braun's vision, was never the destination. It was the door. The plan was rejected. Within 3 years, the Apollo program was canceled. Within 4, Gene Cernan climbed back into his lander and left. It took 50 years for the architecture von Braun proposed to be seriously revived. The Artemis program, formally established by NASA in 2017, is not Apollo. Apollo was a sprint, a political demonstration of capability, executed brilliantly, abandoned as soon as the political objective was met. Artemis is structured as an infrastructure program. It includes a planned lunar orbital station called Gateway. It includes commercial landers, sustained surface operations, and explicit plans for in situ resource utilization. The stated goal is not to plant a flag and leave. The stated goal is to stay. The program has slipped. Costs have grown. The first crewed landing, originally scheduled for 2024, has been delayed multiple times and is now planned for no earlier than 2027. Some of the technical risk has not been retired. None of this is unusual for a program of this scope, but it is worth saying clearly. What is notable about Artemis, regardless of its execution problems, is that it represents the first serious institutional commitment to the stepping stone architecture since von Braun. The argument that we should go through the moon is no longer a fringe position. It is the official policy of NASA, the European Space Agency, the Japanese Space Agency, the Canadian Space Agency, and, through parallel programs, China and Russia. The moon is suddenly crowded again. China's Chang'e program has returned lunar samples, landed on the far side of the moon, and announced plans for a crewed lunar landing by 2030. China and Russia have signed an agreement to build a joint lunar research station called the International Lunar Research Station. India landed near the lunar South Pole in 2023 and is planning crewed missions in the 2040s. The United Arab Emirates, South Korea, and Japan have all flown or are planning lunar missions in the coming decade. The reason for this crowding is not nostalgia for Apollo. The reason is that every major spacefaring nation has independently arrived at the same conclusion. The path to Mars and to the rest of the solar system runs through the moon first. I want to step back from policy and engineering for a moment. We have not sent humans beyond low Earth orbit in more than 50 years. Every astronaut who has flown since Gene Cernan left the lunar surface, every cosmonaut, every taikonaut, every crew member on every shuttle and station and capsule has flown in a band of space less than 500 kilometers above the surface of Earth. That is roughly the distance from New York to Pittsburgh. Less than 1,000th of the way to the moon. We have, in other words, lost the institutional memory of how to send humans to other worlds. The engineers who designed Apollo are mostly dead. The supply chains that built the Saturn V no longer exist. The procedures, the training programs, the medical protocols, the psychological frameworks, all of these have to be rebuilt from documentation and inference. We are, in a real sense, learning to walk again. Capabilities once lost are difficult to recover. The Saturn V cannot be economically rebuilt. The original blueprints exist, but the workforce that built it does not. The supply chains do not. The institutional knowledge does not. NASA has estimated that recreating Saturn V capability from scratch would cost more than developing a new heavy lift rocket, which is, in fact, what NASA chose to do. The same is true in slow motion of every crewed spaceflight capability. Each year that passes without humans operating beyond low Earth orbit is a year in which the muscle memory of deep space mission design atrophies. The engineers who would have designed the Mars mission retire. The procedures get harder to reconstruct. The cost of starting over grows. There is a window in which the Moon-Mars architecture is achievable. The window is not infinite. If the current generation of programs fails or stalls, the next attempt will start from a worse position than this one. The institutional knowledge will be further degraded. The political will may be harder to assemble. The cost will be higher. This is not an argument that we have to go now or never. It is an argument that the cost of waiting is not zero. Every year of delay is a year in which the path becomes harder, not easier. There is a photograph I want to describe. It was taken on December 7, 1972, by one of the crew members of Apollo 17. The same mission that Gene Cernan commanded. The spacecraft was about 29,000 kilometers from Earth, on its way to the moon. The crew turned the camera back toward home and took a picture. The photograph is called the Blue Marble. It is one of the most reproduced images in human history. It shows the full Earth, fully illuminated, hanging in black space. Africa at the center, the Arabian Peninsula at the top, the Antarctic ice sheet at the bottom. What is striking about the Blue Marble is not the planet. We have seen the planet many times since. What is striking is that this photograph was taken by a human being who was traveling away from it. A person in a small metal capsule looking back at the world from a distance no human has reached since. There are no photographs like this from the last half century. There are photographs of Earth from the International Space Station, but those are taken from low orbit. The Earth fills the frame because the photographer is barely above it. There are photographs from uncrewed spacecraft, but those were taken by machines. There is no recent image of the full Earth taken by a human being who is moving away from it. This is the most concrete way to describe what we lost when Apollo ended. We lost the ability to look back at our planet from outside, not symbolically, literally. There is no human alive today who has seen the Earth from far enough away to fit it in a single photograph. Going back to the moon means, among other things, that someone alive today will take that photograph again. Someone will stand on the lunar surface and look up and see the Earth, not as a horizon, but as a sphere, a small blue, fragile sphere hanging in the black. And from there, they will look in the other direction. They will look toward Mars. That is what the moon is for, not as a destination, but as a vantage point. A place from which the rest of the solar system becomes visible, not just in the telescopes, but in the imagination. A place from which Mars stops being an abstraction and becomes the next obvious step. We are not going back to the moon because the moon is interesting, although it is. We are not going back because the moon is valuable, although it may be. We are going back because the moon is the only place we can stand and see with our own eyes that we are not bound to this planet. Gene Cernan, on the last rung of the ladder, said we would return. He believed it for the rest of his life. He did not live to see it. Someone watching this video will. The moon is the door. We opened it once, looked through, and closed it again. Now, slowly, we are reaching for the handle. We cannot skip the moon. The moon is how we remember that we are the kind of creature that can leave.